Hi everyone. Today we're going to graph an absolute value function. There's going to be 3 different ways I'm going to show you that you can do this. And this is the first way. One way we can graph absolute value functions makes use of our piecewise definition and allows us to write the absolute value as actually a 2-piece function for 2 different lines. If you remember our definition for absolute value, we need to consider 2 cases about the expression inside the absolute value bars. We can find this by setting up and solving the inequalities. 3x minus 8 is greater than or equal to 0. By solving the inequality, we get x is greater than or equal to 8/3. And then solving the other inequality, 3x minus 8 is less than 0, we get that x is going to be less than 8/3. One of the things that you're also going to notice is that 8/3 is the point where the graph is going to change pieces. So it's also really important that we find the value of the function at 8/3. And when we substitute 8/3 into the function, we see that we get 0 inside the absolute value bars. So absolute value of 0 is going to be 0, and then 0 times -2 plus 1 is going to be 1. Therefore, we know that our vertex is going to be the point 8/3, 1. Now we're going to apply our definition of absolute value. We already found on what domain the absolute value expression is positive and on what domain the absolute value expression is negative. So all we need to do now is actually apply the definition and write the new expression. So for where it's positive, the expression inside the absolute value bars is going to be the same. And for where the expression inside the absolute value bars is negative, whatever is inside the absolute value bars is going to be the opposite. After distributing and collecting like terms, then I'll get each piece of the function for each domain. So for the positive part, we'll have negative 6x plus 16 plus 1, which will end up being negative 6x plus 17. For the negative part, the expression inside the absolute value bars is going to change to negative 3x plus 8. Notice how the negative went to both terms. Then when we finish distributing and collecting like terms, we'll have 6x minus 16 plus 1, which will end up being 6x minus 15. So, to actually plot this on the graph, first I'm going to use the vertex, and then all I need to do is use the slope of the line. On the right side of the graph, on the domain 8/3 to infinity, or I think it's much easier to use the mixed number form, 2 2/3 of the number, to be able to see where it is on the graph. I'm going to use my slope, which is -6, and just go down 6 as I go over 1 on the x-axis, which will put my point at 3 2/3, -5. And then I'll do the same thing for the other side. The slope is +6, so if I go backwards 1, I'm going to go down 6, and then I just connect my dots. If I were to extend both of these lines, they actually would go through the y-intercept. The line on the right side of the graph would eventually go through a y-intercept of 17, and the line on the left side of the graph would eventually go through a y-intercept of -15. So, that's how you use the definition of absolute value to graph a function. If you don't like this way, don't worry. There's 2 other ways that we'll look at how to do this, and maybe you'll like one of them better.